Oh, look, we're going live. Yep, it's definitely gone live. Welcome, welcome, welcome to Amber Skies. And what are we on now? Day 19? Day 19 of our Mission Impossible to do an MMO. An online MMO. Well, a network with some 3D stuff on it. Yeah, that's more like it. Let's be realistic. How do you like it? That's my setup. As you can see down in the bottom right, there's a little HP server. Just down in the bottom right, you can't see the pointer, can you? Oh dear, if I do that, yeah, you can now. There we are. There's a little HP thingy down in the bottom right here. That's my server, and that's the keyboard for the server. There's a Linux machine dedicated. That's going to be hidden under here. And there is a dual purpose computer, which you can just see down here. It's got no fans, and it's Windows and Linux. So that's Windows I'm showing there. That's Windows 10. Isn't that good, hey? So that's what I use to broadcast from, but it's in Linux mode at the moment. As you can see, I'm using Kryter, so it's definitely in Linux mode. Alright then, so that's a little tour around my office, and this is the ship's cat, Muppet, who guards me day and night, and of course my microphone system's over here. My calendar's there. And my big speakers there, my little speakers are down there. Yes, we have sound as well. And a remote control hiding under there. Medication, glasses, glasses case with clippers in. Yeah, this picture says it. This is my life. This is how I generally spend each of my days. Thought that would be a bit more interesting to people rather than just seeing the normal screen, so I thought I'd pop that picture up for you because I had it lying around. There we go. I've popped it up, and I hope you were quite happily yummied by it. And today is just a continuation of yesterday, really. We're doing shaders, aren't we? Today we are going to do two new shaders. We are going to do amber texture. And that's going to be a vert. And let me just set that up first of all. Copy. And paste. So at least we start with something. I mean, that's the best thing about this. So that's amber vert. We don't need main at the moment either. Amber texture vert. Let's start the next one, which will be amber texture. And that's going to be a fragment file. So .frag. You can call that .f or .v. You can sometimes it's .fs and .vs. All depends upon your style, I guess. I don't really care. So let's just have a look at the color frag and give ourselves something to start with, shall we? We'll give ourselves that. I mean, that's only fair. Texture fragmentation, we'll pop you in. Saves us a bit of typing in the long run. And we can get rid of you. And we can get rid of you. Because we're not interested yet. Right, so here we are. Amber texture dot vert. Can anybody spot what we don't need if we're doing textures? I just realised something. How do I how do I know if there's anybody? Am I talking to anybody? Whoops! It's not on this screen. It'll be on the other computer, won't it? Where's that gone? Got my activity. Ah, there it is. I found it. So yeah, you were supposed to be over there. You were supposed to be there. There. Oh god, that's gone all wrong on me. Blades, Blades. You're having a moment. Come on. Oh, bless. And I just need to do that, and I can see the viewers. So, let's type the message in. We type it in here, don't we? Welcome to Amber Skies. The home, woohoo, I've done that well. The home of 3D and networking, yes, Amber Skies. I'm Blades, and this is a texture vertex shader. What don't we need? Let's have a look at this little baby here. All we're going to do is replace our colour with a texture. Wow, that's good, isn't it? And it's a vector. So what we're going to call it? Texture coordinates. So texture. I'm not doing coordinates, so we'll do co-ord. Yeah, that's fine. That's fine. On the outside, it's going to be vec2. And it's going to be not colour anymore. It's going to be text coord. There we go. Not text, text. Texture. So that's that bit done. Model view projection, light position, yeah, that's normal. Surface normal to light vector, yeah, we'll still need all of those. Am I happy with that? Yeah, except for this line here. So this line here just gets replaced with v underscore text coord equals, you guessed it, texture coordinate. Yeah, that's simple. The lighting is the same, and the world position doesn't change. All of those calculations stay the same. So that's the alterations. All we did was replace colour with texture coordinate. Fantastic. I already like this. The less you replace, the easier it is to do. There we go, that's our texture vert. Let's have a look at our fragment shader. So we no longer have it. Oh, did I put that right? Vec2. Yes, I did. Good. Fragment shader. Vec2. Actually, it's got to say the same, hasn't it? So, stop any mistakes. Except for cut and paste mistakes. So in our fragment shader, that's going to be taken in. Okay. Lovely. Nothing else has changed except for one uniform. We have to add one. And this uniform is the most important because it's going to be the sampler. Now, on a graphics card, we have things called samplers. for textures and things like that. And we can use them, which is very nice. So all I'm going to do is put in a uniform, and it's going to be the type is a sampler. No, it's not going to give it me, is it? I just realised it's not fully Dubry 2D. And it's just going to be the texture. This holds the texture. And we'll sample that texture at the correct points to place on your model. So it's going to be an U underscore and texture, because that's what it is. There we go. So using the lighting, we've got ambient light, yeah, that's okay. Diffuse light, yeah, looks alright. Specular light, that looks alright. And we should come out of that with a clamp for final lighting. So the final fragment colour is now not going to be lighting times V colour. This is a bit that changes. And this instead is going to be a wicked little thing, because it's going to do it for us. So what we're going to do is we're going to take a texture, or we're going to create a texture anyway to multiply. And it's going to be the texture that we have for the model, which is that one. And we're going to ask it to sample it. So that will sample at the coordinates given by v underscore text coord. That's it. That's all it is. That's a function that's given by the graphics card. That's on your graphics card. So, yeah. That didn't take long. So we just created two new shaders from our color shader and replaced color with texture. So we now have two sets of shaders, which we can compile and put the programs onto our graphics card and ask it to run them. That's very clever. That's called rendering. So there we go. Done. Not very difficult, I must admit. So, yeah. I'll keep that open for a minute. Alright, what I'm going to do here is test it. We need to test it all at this stage to make sure that everything's working, otherwise we are wasting our time, obviously. We have a main window, which I don't care about right now. I just want to test the... So let's just put in test read text. So we've just done a load of text, haven't we? We just put a load of text in for a shader. I'll show you the first one. The first test is always the simplest, because what we do is let's have a look. We receive that back. So we'll need one of them, whatever one of them is. Let's have one of them. So one of them, and we'll just call it text. Text in. There we go. And that's going to equal read text file, and then it just wants a path. Okay. So that's read. No, it's amber, isn't it? See what we've done with that. Amber 3D, okay. So Amber 3D, colon, read my text file in, and we'll have, to start off with, we will start with main.cpp. Okay, that's a text file, because we're writing in it, so it must be a text file. And then what we're going to do is a for int, no, not an int. It's an unsigned int. U int count. Is that right for a uint, or is it just uint as small? That's interesting. So that's legal, is it? I don't understand that. Let me just do that again. Uint comes up with all these, and then it gives us uint there. Goes purple, and then turns yellow. Okay. Fair enough. As long as our count is less than text in. This is how you use text in, by the way. Dot size semicolon count plus plus, is it? Yeah, we'll do that one. Okay. And all I'm going to do now is SDL underscore log, open brackets, %s, comma, text in, open brackets, count, close brackets, semicolon. And it says it's legal. Shall we find out? Should we try running that? Well, first of all, I want to try building it. Test, please. Warning, %s expects argument of char star. Why? Why? Is it one of them? C underscore str string. Okay, dot C underscore str. Oh, that seems to have worked. No, it doesn't. I can't remember which way round it is now, but is it the address? No, is it the star? No, is it me? Why me? Why today? It's a small s. Okay, are you happy with that now? Are you sure you're happy with that now? Good grief. Run build task. I don't ignore warnings ever. I mean, it would have done it for me. But argument 2 has const string. No, it doesn't. Okay. Alright. Const char. Text line size 255 maximum equals text. Just copy and paste it. We have to convert it to C. Why do we have to convert it to C? Because, yeah, reasons. Const char star. Okay. What's wrong with the const char star? Oh yeah, you've got to take the star off, that's why. Duh. Okay. What's wrong with text in? Oh right, okay. That's fine. Text line. Equals this. Why can I not put text lining equal to that? Why am I having such a hard day? Mm-hmm. Dereference it? No. Why can't I make one variable equal to something? Because it's a const. Okay. Yeah, okay. You can't change the value of a const. A value of type const char star cannot be used to initialize an entity of type const char. Alright, what does it now say? A value of type const char star cannot be used to initialize an entity of type const int char. Where the hell did int come from? Got it. It's me putting me stars in the wrong places. So this says it's happy, but it isn't. So we'll take text line and we'll copy you into this space here. Blooming stars. Okay, I think that's now good programming. Well, yeah. Run build task. No, it doesn't. It's not complaining about that one. Oh, bollocks. It's complaining about a different one altogether. Line 68. I should read the warnings. Okay. I know this one will work. Right, okay. Save. Terminal run build task. Okay, I've gone all the way around the houses to do something simple. Yes, I know. Let's run it. Let's see what this test will do. I'm not interested in the window. I'm interested in what it does in the bash. Okay, we had a warning. And we had a bracket. Okay. So we got the end bracket. I'm not happy with that. Let's do it in C++ then instead. Totally. So that's a bad test. It didn't give us the right result. We need a test to give us the right result, otherwise we can't continue. That's why we've got a test 3D. Okay, unable, that's okay. Right, alright. Let's write our test. Because this is rubbish. Obviously. IO stream's already in. So what we're going to do here is take you 2 lines out and start again. We're going to use std : C out. And we are going to just see out straight off text in count. And then we're just going to introduce an end line. I don't know if we need it or not, because the end of the line might already have an end of line. Does that make sense, or was I just talking gibberish? I was just talking gibberish, that's good. Normal, everything's normal. There we go. So, text in count, blah, blah, blah. Will that cause any errors? No, it will not. Oops, wrong one. We got an address. Don't tell me standard cout needs const jar stars as well. We just got an address. Well, that's wrong. No, it's not. Well, yes, it is. No, it's not. Yes, it is. No, it's not. Are we only getting the last character, or are we just producing a mess here? I think we might need a buffer. We can't return text file. Yeah, that's right. Okay. Count is less than text in size count plus plus. Yeah, that should be going round quite nicely. By the end of this, what is count? Oh, sorry. STD. Oh no. SDL underscore log. And count equals %d u. God, that was a quick count. There we go. Diddly-dee-dee-dee. Testing, testing, testing. My testing goes well. Always does. Even though I know everything equals the correct thing. Count equals 1. Okay. I'm just wondering why. Because it's giving me the address. Yeah, okay. So yeah, that will equal 1. But why? It should still count past it. It should give me all the addresses. That's interesting. SDL underscore. This is where SDL log does come in useful. Because you can do different things with it. And what I'm going to do is size of file number of lines equals, and it's going to be a %u, and it's going to be text in dot size. Let's just find out what that number is. Okay. 1. Yeah, let's just get you out of the way a minute. So I can pull that down. Yeah, it's telling me that the number of lines equals 1. So there's something definitely wrong here. And yes, it is an LU. Sorry, nearly got it right, but not quite. There you go, put an L in front of it. Is that why this is failing? Oh no. It isn't. But we are only getting 1 returned, and it's the last 1 returned. So we're actually sending back the wrong thing here somewhere. There's our pushback. So our text file has our pushback in. Okay. uint count. Equals 0. Okay. Our pushback's outside the while loop. What's our pushback doing outside the while loop? So it'll only get the last line. Da-da-dum-dum-dum. That could be an error. That could be an error. Let's do that. Let's ignore that count line. I was about to count out how many lines there were there and compare. But I can already see there's a problem. That we're not pushing back enough blooming lines. In buffer blah 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 get line blah 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 blah. Do it again. Push back, push back, push back. Let's try that one. Just run it. That's better. That's what I would have expected from the error that I'd caused. There we go. 128 lines. I'm not really bothered about that addressy thingy. I just want to know whether it's 128 lines or not. It is, and it should be 129. Hello. I just got a beep beep. No? Yeah? I'm sure. Did you all hear a beep beep? Oh, I've got a reply. Okay. Oh, right, yeah. Sill's just asking me. He's got builders in. Let me just connect. Yeah, doing good. Day. What are we on? Day 19, 18, 19. Oh, I can't see. Day 19. Wow. Twitch doing the 3D stuff. There we go. So it came out with the correct number. Which you can't see because I haven't put it on screen. There you go, 128. If I go back up, it's just each memory address. Size of file 128. That's correct. That is correct. How do I print out what the contents of a memory address? I think it's an AND. Contents. Dereference. Which could be a star. I can try that. Try dereferencing it. Seeing what comes out. Good stuff. And so, here we go. Now, it hasn't shown it. That space that I put at the bottom, remember? This is important. There is a load of gobbledygook on that next line where it says press any key to continue, because I closed the window. It will have a load of gobbledygook, and that is how it does its file control whilst controlling on the hard drive. Now, because I pushed that extra space in, it had a space in which to put an end of file marker or a bad marker. And that means at line 129 is the final line. It's got a space there in which to put the bad marker so it can terminate before it goes into the gobbledygook stuff for the hard drive. And there's our full main program. That's main. All nicely done. Now, as you can see, all the way up to all includes. So, to make sure that this isn't just a one-off, we'll grab a shader. We should be able to do this for a shader now. So yeah, I just had to dereference it to get the stuff out. That was all. So here, what we can do is we can type in, let's say, a vertex shader. Let's have amber color. So we will go dot slash shaders dash amber color, and we'll have the vert one, please, dot vert, and see what that does. We'll just run it. There we go. There's the screen, see-through screen. There's our 30 lines of code. As you can see, lighting stuff, and it's got all the welcome. Size of the file is 30, version 330, and then it has all of our lovely code. Is it 30 lines long? That's what we need to know. So I'll close that window. We have to make sure that that is 30 lines long. By heck it is. Yes, we have success. And that's why I needed to test this. That's why I wrote the text reader first. Is not because I'm trying to prove anything. It's because I need to know what that last line is. Because if it's gobbledygook, we're going to crash our graphics card. If it's not gobbledygook, we're in the clear, we can compile this, it's going to work. Ta-da! So, we have shaders that work. We have a reader that works. Delete. It's a nice little test. Test done. Okay. So now we have that. We really could do with compiling those shaders, couldn't we? Yeah, I think we could. What's the best way to compile shaders? Qt. No, don't say that. Qt has fantastic compilation of shaders. It's built for it. So much damned easier than C++. But hey ho, we have C++, so let's use it. Shader building. So now we've got that done, complete next texture. Let's build shaders. Yeah, build shaders and place on GFX card. In other words, not on our normal memory. So that's the next goal. Build and place on GFX card. It has to return something. So the graphics card has to return something. So and store the handle that the GFX card gives us. So what the graphics card's going to do is give us a handle, and that handle will say, if you use this handle, you can use that program. Because we're going to generate two programs. We're going to generate one called color and one called texture. So there's going to be two programs. There will be two. Yeah, normally people just start off with one shader, a very basic shader, and build it up. Nope, I start off with two shaders with full lighting and say, yeah, we're going to build them. There will be two programs. That's what they are. Programs stored on GFX card. So we have to make these into programs. At the moment, it's just like C. So we need to compile them and link them. Yes, we have to link them as well. And obviously place it onto the graphics card. So it's compile, link. Ta-da! Done, I guess. Have I got anything that's a good way of doing this? Just have a look. Nothing there. Oh, this might be useful. What's this one? Yeah, this one's useful. Right, let's make some programs then. Some interesting ones. This is reader text file. Yeah, we're going to need that. What we're going to need as output is a uint. The handle is actually going to be a uint. Well, it's going to be an integer, but a uint will store it. But no, because it can't go into the minuses. A uint of 0, by the way, means nothing. If you hand your graphics card the handle 0, it will just cancel the function that you've passed that 0 to. So if it's running a program, once you've finished using it, you hand the graphics card the handle 0, and that will clear that program from use on your graphics card. It doesn't destroy the program's still there. You just give it the correct handle to use it. It's a very, very nice switch on, switch off mechanism for using programs on graphics cards. And considering how many there can be, if you look up shaders, graphics card shaders on the wiki, I don't know how many details. Let's have a look. What the heck? We're doing shaders. Let's have a look. There's no problem with that, is there? So, graphics card shaders wiki. Wikipedia. Okay, it's going to shader. History of design types. Okay, we have 2D shaders. We have pixel shaders, 3D shaders. We have vertex, which we're using, geometry, tessellation, primitive, other compute shaders, obviously for CUDA, parallel processing shaders, programming shaders, that's GLSL. It has missed out the frag shader. Why has it missed out the fragment one? Interesting. I don't know why. It's one of the most important ones going, and they've missed it out. Fragment quads. Or is it here? Yeah, it can do fragment quads. I know that. But the problem is, OpenGL 3.3 draw GL elements doesn't do quads. It does triangles only. You can't do quads. I know, because I found out the hard way. So yeah, there's a bit of information on here, but that's way low. I'm guessing there's over 10, way over 10. This is just very basic. I mean, yeah. He doesn't even say there's a fragment shader. Wow. I'm gobsmacked. Sorry. Oh, no. No. Take that one away. Don't take my program away. I want that one. Okay. Do you notice how it all clicks in when I do that? So if I go to, like, there you go, just clicked in. Why doesn't Windows do that? Linux does. They can implement things that Windows can't. Let's start with... we've got to do them in reverse order, haven't we, really? Or some silly order. Right, we'll need some way of checking them then. Okay. How do we check them? If we check them and they fail, obviously our whole program's going to fail. It's going to be useless to us. So it'll probably crash the program if we failed. So let's void. So it may as well be void. Check. Because we're going to be compiling these. Compile. Error. And there's tons of different stages at which we want to check for compilation errors. There is both the first compilation we want to check, then we want to check at the link stage, and then we want to check after the program has been compiled. So there's at least 3 different stages where we want this function to work. So we'll use a uint ID. That will be the identification of what we're checking most likely. We'll have a uint flag of some type. That will be... is it type? Well, the flag usually tells us whether it's vertex or fragment, I believe, if I can remember rightly on this. I think so. We need a bool, because we need... I hate using bools. And we're just going to put his program. Because obviously we have to do a final check on the program itself, so we'll have to turn that to true. For that, and a const std : string and error message. That's the error message we're going to tell ourselves if it fails, because it's a void. We're not coming out of here if it fails. So we'll have to put our error message at this point. Instead of saying SDL log, we'll give it to the compiler, the checker, to issue out if it's needed. So error message. Okay, I think we can do it with that. Alright, so we'll have one of those. Don't know which order we're going to need these in yet. What else are we going to need? We need to be able to load them. Yeah. std : and it's going to be a string. Yes, it's just going to be a string. Load shader. Ah dear, load. I'm just trying to think how all this is going to work. Yeah, it'll be alright. Const std : string. We'll have a file path, is it? We're using file path, yeah. And file path. Okay. That's all we're going to need in it. Yeah, I'll go with that for now. I'll go with that for now. Oh, sorry. My bad. So used to doing that, aren't I? That's the loader. I will need a uint. Let's compile shader here. Let's have a compiler for it. We'll write a compiler. Now this is different in that I'm going to just take in and its shader name. No, just one M. The reason I'm doing that is because all I want to know is the amber color, amber color or amber texture. I can tell you what the rest of it is. I can tell you what the rest of the file path is just by the name. So I know it's .vert.frag, and I know it's in shaders. So, and they're not moving anywhere, they're not going anywhere. So, unless you move them, and then you've got to redo this, I suppose. Oh, bad programming, good programming. Who knows? Who cares? Next, it's a prototype. So that's compiling, and we want the entry point, which is create shader. And that's what we're actually going to call ourselves. And it's going to give back the uint, which is the handle, I hope. Create shader. Okay. This is the one where we have to start. So that's const. And that's... Oh, wait a minute. I think I got this wrong, you know. I think that goes at the bottom. I think that's one we're calling. Yeah, I'm wrong. Something wrong with being wrong. It should be this way round. I'm just looking at, thinking about it there, and I just came across in my mind, hold on a minute, if when we create a shader, we're going to need a const std string, and that's just going to be the text, isn't it? And text, yeah, because we're going to need it, we're going to load it, then we're going to create it, and then we're going to compile it. So load, create, compile, and check for errors. Yes. Load, create, compile. That sounds better. Okay, that brings back a memory, so yes, I'm doing it right now. And we'll need this as GLenum, which means we need OpenGL. We've got it. Lovely. Next. Shader type. Have we got it before we call it? We have to call the window before doing this. Main. Yeah. Okay, bin that. Alright, that is no longer part of the test. So it goes here. Okay. This is no longer part of the test. The window is now no longer part of the test. Shouldn't we destroy that window? I think we should. Isn't something about that? SDL underscore. Is there a... There's destroyed textures. Yeah, there is. And we've got... no, we haven't got. We've got main window. Window 3D. And what's wrong with that? It needs to be a star. We haven't made it a star. Okay. Address. Pardon? Oh, stuff it. And no, that is right. And semicolon. I think it's because I didn't have the semicolon in. But this is just the address you want. Go away and stop me. What is wrong with that? Oh, right, that has to be in the window. Oh, okay. The window has to do that itself. Let's make sure the blooming window's doing that, shall we? Now thought of it. We are using GLFW, are we? No SDL. That's a good point. Yeah. Let's just make sure SDL window is actually destroying itself. Now thought about it. Oh, it's not. I didn't know that. SDL underscore destroy. Missed something. Destroy window. Open brackets. How do we create it? Initialize window. End window. There we go. That'll work. Wow. Can't believe I just forgot to do that. Who does SDL? We do. We initialized it. Okay. That's fine now. I'm glad I remembered that. Because I knew that if I forget it, if I've forgotten it, we do get a well, we don't get a memory leak actually. The Windows system behind the scenes will also do that for us, but we're being lazy, and you should never be lazy. So I'm glad I thought about that. Right, let's do these back to front, I suppose. How shall we do these? Let's get Kate up. Come on, Kate. You got any notes on this? Oh, Jesus, you have. Oh, this looks awful. This is going to be fun. Okay. Compile shader. Right, well, before I do this, I need a drink. Okay, got some burpy liquid here. How are we doing, viewer? Are we alright? We're about to compile a shader. Wow. The easy way, I think. The quick and easy way. It's how we're going to introduce all this code into our code base that worries me more than anything. How long have I been on? Alright, we're just over the hour, so I can have a break if I want one. Let's get this started first of all. Because I am sweating cobs. It's hot. It's hot, everybody. It's hot. And I shouldn't really be doing this when it's hot. So let's do some storage. std ::, string, file name will do. Yeah, so that we can use our shader name. There we go. Just pop you in there, because then it's safe. Return uint, return uint, return string. std : string temp equals hello return temp. Here we want uint temp equals 0 semicolon return temp. Very big programs. Okay, that's going good. You want a uint, don't you? Okay, we'll put a uint in then. So we're going to have a uint program ID equals 0. As I said, 0 means switch off. So we can now return that. Return program ID. Okay. We've got a better program now because we've modified it. Okay. All unused. Yeah, that's good. That's what it should say. Lovely. All of these just unused, that's all. Okay, let's build a program. Right, so there's a vertex and a frag. Okay. Uint. So we're going to get the results of two things. They are shaders. And we need two of them. And we can equal those to a base value of 0, 0. Semicolon. So those are initialized. That's okay. Right, I think we can start the program with that. Well, we can start the real bit of the program now. So, program ID. Program ID, that one. Equals GL create program, I guess. That's that one. Let's put some brackets on that. Didn't want anything, did it? A gluint star. Okay, fine. Semicolon. Alright, so that gives us the identifier for the space. That's the handle that we're going to keep. We have just created some space on the graphics card to put the programs in. So let's do the first shader, shall we? It's going to be shader 0. So shaders 0 is going to equal oh god. How's about create shader? The next one up, yeah. Create shader. Open brackets, that needs things. Standard string and text and a GLEnum. So create shader is going to be open inverted commas dot slash, and it's shaders, isn't it? Well, that's where we put them. Slash plus file name. Why is that bad? Oh, it's not. Okay. Plus open inverted those again. Do we need to tell it it's a vert? Yes, we do. Because we're going to do this twice, aren't we? Dot vert. And comma. What's the enum? GL. And we're using vert. Oh, good. Vertex we have. Good. What else is it? It's a shader. Yes, we have GL vertex shader. It is an enum after all. A GL enum. I think that's all we're going to need. Yeah, okay. So that will give us a vertex shader. I think we can do exactly the same. Shader 0 equals create shader open inverted blah blah blah. So blah blah shaders. Just make sure I do it right. Is it plural or not? Yeah, pluralized it. Again, plus file name. That's how I spelled it, isn't it? Yeah, okay. Plus dot frag. So that's our fragment shader, which will be GL underscore frag. Okay, fragment. Yeah, we've got it. Shader. There it is. So we've got a vertex shader and a fragment shader. We're going to be ask for those. We're going to give the full file path and the file name for each of those. So the shader name, all we have to do is now pass in either amber color or amber texture, and it will be able to create those shaders. And that has to be a 1. That's good news. Okay, so we're getting some shaders. Now, what we're going to do for those shaders, well, we can attach them, can't we? So what we need to do is we have to attach those shaders to the current program. Okay. So it's GL attach shader. Thank you. You're going to need a program. Program ID will do that for us. We've got one of them. And you'll need a shader. I'll take shader 0 then. Shaders 0. There you go. And I'll attach the other one as well. GL attach shader program ID, comma, shader please, shaders 1. There we go. Right, so we've attached to the program our two shaders, our vertex and our fragment shader. At this point we should bind attributes. At this point. And I'm not going to. You see, at this point, it's the last point where, because at this point they're going to probably be assembler, God knows. Probably be an assembler language or something. What that attaching does, by the way, is put them on the graphics card. If you're wondering what attach does. We could bind attribute locations at this point for the shaders, but as we are dealing with multiple different shaders, I'm not going to do it. Okay. So the next line is GL bind attrib location and then it would be program ID, comma, name of attribute goes into there. Use this if you wish to. I'm not gonna. Done it. Not for a prototype anyway. So I now have the shaders right where I want them. They're on our GFX card. We need to link them. So after I've finished binding all the attributes, like position, colour, different things, whatever there's in there, what that bind attribute thing refers to is binding these attributes, so position, normals and colour, you'd do, to 0, 1 and 2. Is there any point in doing it, considering I've already declared to the graphics card that they are going to be in location 0, 1 and 2, so I'm going to know where they are anyway. Why bind them if you know where they are anyway? Because all that does is give us 3 extra variables that we've then got to look after. Or, well, we'll know that they're in 0, 1 and 2, but we already know they're in 0, 1 and 2, so it's a complete waste of time, I think. I just think binding the attribute locations is a waste of time. And I don't know if anybody would agree with me, but hey ho, let's link them up. Let's charge up the linker. GL link, I suppose. Is it a capital L? It is, but it's GL link program. That'll do. And that takes program ID. It's got all the information now that it needs. We've attached the shaders. Program knows where everything is. It's happy on the graphics card. Do the linking, graphics card. Go ahead. problem? What if there is a problem? We better check for compile errors at this point, otherwise really we could accidentally do stupid things. Alright, what do we need? We need a uint ID. That's going to be the program, isn't it? Yeah. So we need the program ID, comma. We're going to pop a flag in there, which is going to be GL link status, because that's the one we want to check against. Is it a program? Yes, true. And an error message. Error colon GL link program failed. Because I'll know where that is. It's right in front of me. There we go. Right, this is going to be interesting. We've just checked the program. Alright, what we now have to do, this is going to sound really stupid. We now have to ask our graphics card to check the program and validate it, or it won't run it. So GL validate. This is just telling our graphics card to make sure this program, it actually does a test run. So can you please run it, test it, see that it works. And this is just for our program ID. So once we've done that, this now gets silly. We're going to check the checker. So we're going to do another one of these. Because our graphics card might come up with something. So we better check if it came up with anything. All we do when we check compile error is we're checking if there's an error produced at the previous stage, which is link there, validate here. So only looking at the errors that the graphics card is coming up with, and we will print out if there are any errors that it finds itself. So that's validation. So validate program failed. It's not GL link, it's GL validate status. Validate status. There you go. So it's program ID. Yeah, that's good. All right. I think. Yeah, that'll do. Right, that's it, done. That's all we need to do. If it's made it to that point, we have a program. We can return the program ID. If it can make it past all these error checks. I know it's a prototype and I wasn't going to do error checking, but considering I want a full, I really don't trust other people's programming. I think we have to do error checking. Remember, somebody else programmed that graphics card, not me. Well, actually, it could have been. You don't know, do you? So, look through that. Any questions on that? Let's pop this up. I'm going to have a break. I need what colour will work on here? I don't know. Let's try black. Yeah, let's try black. No, No, that's white. Oh, that's the rubber, isn't it? What? What? Get out of it. Get my picture back. Black. Does that work? Okay, yeah, that works. Fantastic. I like things that work. Whoops. Don't do that. Okay. Where's my pen? Alrighty. Take a break. Seven mins. There we go. The writing is on the wall. Okay, we've taken a break. The writing is on the wall. That was a funny one, actually. Save as no. Open recent. There we go, that takes it off. Thank you. We're back. Just one sec. Close the door from added noise. I've got a cup of coffee. I'm a coffee drinking Brit. Call me Dave. If anybody knows that joke, good on you. Right, so we can compile a shader. Terminal, run a build task. Okay, all compiles. That's good. Let's do the next bit. This is creating a shader. Okay, so this is singular now, is it? Yeah. So that was compile. How do we create a shader? Okay, let's create a shader. That can go. What will we be returning? A shader, I think. Yeah, we will. So we'll return a shader, a uint. Uint shader. There we go. That solves that problem. And that becomes a shader. Okay. And that equals... oh, yeah, that's going to be easy, isn't it? It's create a shader. I just remembered what this is. Yes, shader. There you go. There's the shader. That's the thing that we will be creating. And did it give me a pop-up? GLE star. GLE num type. Yeah, that's not going to help, is it? Shader type. Okay, we did give it, didn't we? Yeah, we did. So that's going to be shader type. That's better. That works, you see? You see how simple it is to create a shader? Yeah, that's remarkable. Okay. We should do a check here for whether it got created or not. Okay. If shader is equal to, remember what I said about the 0 being important, it means that the graphics card has no room for a shader and can't make one for us. Yeah, that'd be funny, wouldn't it, nowadays? But yeah, okay, we'll do it. And we will use SDL log. What we're going to log. How's about failed to create the shader? Don't know which one. There you go. And exit. And I use 99. For crash exits, I use 99. It's just a personal preference. 99 is an easy one to realise, hey, this is me that's crashed the program. This isn't the program just going silly or doing something stupid. It's me, I've crashed it. Yay! Okay. Right, so we need two parts to a shader, don't we? A vertex and a fragment. and this is going to be the vertex shader. So we're going to need storage for it. And unfortunately, OpenGL is in C. Why? Yes, OpenGL is in C. Const char star, here we go. Oh god. Char star. And we're going to call this shader source, because it's the source code. So the shader source code is a const char star, as we know. We'll only need one of these. And we'll have an int, and that's going to be shader source length. I'm going to do this in a weird way. I'm going to make it an array, because that makes the name into a pointer, but it's still just an array. We can call it with zeros. Big reason for it, because this is your storage area. This is like a buffer, and this just keeps track of the amount of data that we're messing around with, and it's going to be quite a big chunk, shall we say. So, let's see, we've got the shader, yeah. So I need to load the shader at some point. Where's our loader? Where is our loader? Shoves back a string. Give me a second. Ah, right, I've forgotten something. It's there. So when we call create shader, we should be passing in text. We haven't loaded the shader here. Hold on a minute, our compile shader's wrong. Yeah, we need some strings here, don't we? That's interesting. You create your program, yeah. You create your shader, yeah. But that isn't text, that's a file. that's a file path. That's not text at all. File path. So we're going to need to load them. So we just need to load a shader. Okay, that's easy enough. I can do that. Let's load a shader. GL create shader. Yeah. And if it's garbage, then don't bother. Right, yeah. So the text is a standard string. And that's where the problem's come in, isn't it? Of course. String text equals load shader, of course. And load shader just needs that file path. Okay, it'll do it for us. That's very nice of it. I like that idea. File path, there you go. And that will give us the file path for the create shader. Yes, it's starting to come through now. Right, so we've got our text. So what can we do with it? Yeah, it's in the wrong format for starters, because I just said OpenGL is in C. Oh, that's clever. Ah, bless. Ah. So, we've loaded the shader. We've got, actually what I'll do is I'm going to put that cut. Because I always have a space after these. There. Then what I'm going to do is shader source 0. So, it's not a char star. It is. Oh god. This gets worse. This isn't going to work, is it? It might do. It's just that we need a star for this. Because of OpenGL, it's stupid. Let's see if it does. Shader source. You see, certain things are very weird, and C can handle anything that's weird. So equals text C string. Yeah, that'll work. Yes, because that text then goes into the start address 0, and it's a star, so it counts the whole thing as an address. It's a shader source is a pointer of pointers. So shader source 0 is a pointer, and so is text. Oh god. When it yeah, that is ridiculous. That goes to a const char star. That converts to a const char star. So it needs to go into a pointer. OpenGL, you are amazing. The next line is going to be even stupider. So let's try and work out what our shader source length is. We'll have to use 0, because we're doing this so silly. And that's going to equal... Okay. What we'll have to do is do a static cast. Oh, this is so funny. To a uint. Yeah, you didn't see that coming. And we're going to take the text dot length. There we go. Will that work? Right, what we're doing is we're taking a type size t. We are telling the compiler it needs to be in the style of a uint, which is then automatically converted by the compiler into an int, because that's an automatic conversion. Because the size t doesn't go straight to an int. Size t can only be positive. So it converts to a uint. I don't know why they use size t. They should use uint, but uint isn't standard. Unsigned integers are not standard in C++. So they can't. As you can see, it's not standard. It's not a type. It's yellow, it's not C++. So I'm converting it out of C++ and into C. God help me. That's got to be the most amazing one-liner I've really seen. Okay. What can we now do with this source? We can do something with OpenGL. So, GL, shader, and we'll need shader source. There we go. Shader source, open, invert, gluint, shader. Yeah. Okay, I think we can do that. What do we call it? Shader. Okay, that's easy. That's what we called it. GL size I count is... This is the wrong way round. Why is it the wrong way round? I thought it was GL char star const next. And then the length. Oh. GL size I count is how many shaders do we want? Okay, 1. Now it reads proper. Sorry. So it's shader source. God, reading OpenGL's hints is quite difficult, I think. And the length is obviously shader. Source length. That one. That's it. That's all we need. And now it knows our shader. Compile it, I suppose. GL. Compile. Shader, please. And it just wants to know the shader. I think that's called shader, funnily enough. That's difficult to work out. Oh God, now it's gone and done something, so we're going to have to check, aren't we? Check for any compile errors. This is going to be fun. So we are checking the uint ID, which is the shader. And we are flagging it as a GL compile status, because that's what it's just done. That one, there. It's not a program, so we can false that one out. And the error message. Error. GL compile shader failed. Yeah, I'll do. GL compile shader failed. There we go. That'll do me. Done. We checked for errors. That's it. Next. How to load a shader? Well, didn't we do a test for that? Haven't we already written a program that does it? I think we have. So, how do we read a shader? Should be simple and straightforward. Alright, do we have the full file path? Is the next question. So we load the shader from create shader here. I hope. File path, file path, file path, file path, full file path. Thank you. Okay. Well, it's going to be a standard string, isn't it? I can keep that bit. This is going to look a bit weird. But hey, I don't care. I'm going to take 2. I'm going to take output and line. And line. And we... Oh, God. Wish I wouldn't keep doing that. Line. Missing the key by 1. And we'll return output. So we need to do line by line. There's a reason I don't think we can actually use read text. Yes, we can. Yes, we can. What we can do is we can do a text from here, read the file in. Let's call it read the file in. The file. And that is going to equal nothing at the moment. Let's think about it. The file. Let's read the file in first. Equals. And that is going to be read text file. And that's going to be file path. Is that all it takes? Yep, file path. That one. So we now have the file. And we know it hasn't got the stupid bits at the end because we tested it to find out. So I don't need to clean the file. But we do need to put it all into a string called output. It's got to be one continuous string with \n on it. Every single line has to end in \n. Because I don't know whether that has been provided for us or not. We're using Microsoft, for God's sake. Putting \n at the end of each line isn't one of Microsoft's strong points. Because they use \r, \n. So things could be a bit tricky. We've now got to sort out the whole of the file and put it into output, which is a string. I'll have to do it line by line, and we have to make sure that the line ends in \n. Write that program. Okay. For uint, what we're going to call it? Line count. Hold on. Equals 0. This is why I was testing the for loop before, making sure I could get hold of everything. With that star, we could. So remember the star, line count. So it's exactly the same as what we're doing before on a for loop, is less than the file size. Exactly the same program. Okay. Line count plus plus. Now, this is where the fun starts. Because obviously, we're going to take the line equals it's star the file, remember? And that's going to be line count, isn't it? So we've got that bit. Let's append it then. Output, you're going to receive a line. Output, no, it's dot, and append. In other words, add to the end. Add to the end. Oh God, what we got here? Sugar. Oh, that tells us what we can use. Oh, that's alright then. We'll use that, what we've got then. Line. Yep, line. Plus, opening inverted commas, \n. There we go. That'll do it. Alrighty. What have we got down here? Return output. Done. Next. Yeah, that was it. Dead hard. This is how to write C the easy way. I write in English. If you can't read that and work out what it's doing, line count equals 0. As long as line count is less than the file size, then carry on. Line count plus plus, add 1 to line count every time around. And the line equals the file at line count, and output append line and that \n. It's all important to make the compiler work, because the compiler needs it. The graphics card compiler needs that. It's a specification in OpenGL if you want to go and look it up. So, check compile error. Oh, God. This is the biggest waste of space ever. And we're about to do it. Okay. What are we going to track? Success. There's no return on this. Doesn't need to be. If there is an error, it says something. If there isn't an error, the program just carries on as normal. We'll ignore it. We'll ignore the check. So let's do an int success equals 0. There we go. That's always a good place to start. Now, all we've got to do is check for errors. So we are is in C. So we'll have an error, storage, buffer. We've got a buffer now. We'll have a 1K buffer. So that's the buffer for any errors that the graphics card stores. It will not send them to us. We have to go and get them. So we check if there's an error. If there's an error, we go and get what the graphics card reports or has in its error block, what it's put, tells us what the error is. So we will be retrieving the error from the graphics card. The graphics card doesn't really talk to the CPU that well. That's why we have OpenGL. There you go. So, oh yeah, just realised. Actually, you don't need. Yeah, we'll put it in because it makes more sense to me. No, we'll start it at 0. Oh, go on. We'll do pretty typing. Right. So if is a program. That's been sent in to us. Okay. And we're going to have an else somewhere. Else it's not a program. There we go. There's the code for that. That's nice. It puts star code in it. Yeah, very pretty. So if it's a program, what do? We need to get the information or the vector that gives us the results. I think that's the best idea. Yeah, okay. Let's see if the program succeeded in its last action. So to do that, we use GL get program, and it's IV information vector, I suppose. It doesn't actually tell us there, does it? Yeah. Oh well, it's integer value IV. Weird. Gluint program is our ID, comma. GL enum p name is our flag, comma. GL int star param address of success. I'll have to use the address because he wants a star. Okay, so we've got that. I just realised I didn't have to write that like that, did I? I'm going to anyway. Yeah. ID flag success. That's correct. Okay. Thank you for the code. Ow. On this side, if it isn't a program, then it's a shader. So guess what we put in here? GL get shader. And there it is, IV. And we open the brackets here, and it wants the shader, which is ID, comma, the flag, comma, and the parameter. That's interesting. It's exactly the same, but with a different name. So those are the two. So we can test for the program, we can test for the shader, just from that bool that's been handed in true or false. It can be written shorter than that, but nah, I don't mind. Right, so we've done that. Oh no, it's just going to get silly, isn't it? Yeah, okay. If success is equal to GL false. Yeah, that'll do it. We'll open a bracket. Now, if it's GL false and is a program, see what's coming up next, can't you? Else, thank you for the code. Here we are, we're in the program. I love the way it just extends your code naturally. Oh, this is looking awful. Oh, bless. Right, so we need to get the logs for the program. So GL get program. Doesn't seem to have them. Where are they? Ah, there, that one. That one. Info log. There we go. It needs the program ID. God, this is getting easier. It needs the buffer size, 1024. Oh yeah, 1024. You can put size of error. Oh yeah. Yeah, we'll do it. Size of. We know what size it is already. Error. It's 1024. Comma. Here you go. Size of 1024. I'll do this off over and it tells you exactly what it is. It's exactly the same as that. Yeah. GL size I star length. Dunno. I don't know how long the error is. And the info log we're going to store in error. God, that looks stupid, doesn't it? Semicolon. Yeah. I wonder what goes in here. How's about that? ID, size of error, null pointer error. Yep, that's it. So, if success is we're now here. Space. Output message, I guess. Yeah, okay. STD. We'll send it to the error console, which is a normal console if an error console isn't available. We'll do it properly. Error message. That's at the top, isn't it? Error message. So we'll print out the error message that we gave it. That's a standard colon end line. Okay, and then we'll just do another one. STD colon C error, and we'll give the error that they've given us. So we get the message from the graphics card. Anything else we want to give out? Yeah. We don't want to continue the program if there is an error. And that's it. It's not really that bad. So there you go. That's all we do. We find out whether there's been a success, and if the success is a failure, i.e. false, then we just go grab the error message off the graphics card. We print out our error message that we've done, and then we just print out whatever the graphics card error message is, and we hope it isn't over 1024K, sorry, 1K. Otherwise, it'll just chop it off at the end. It doesn't really matter. Because you should have enough information within the first 1024 bytes. Or 1024 characters. So that's our compile error. Oh, we seem to have run out of things. So what we should really try and do now is load a shader. But every time you... sorry. Every time you load a shader, you've also got to unload the shader as well. So we can create one. So to create one, we just give a name and ask it to compile. And it will check compile errors. It will load the data. There, load shader. Whatever happened to that? I did something slightly different. In the past, I think I used to put load shader in here. But I don't see why you should. Because it doesn't make sense. It should be in the create. You should load it in the create. Because that will then kick off the load shader, which kicks off the read text file. That's correct. That has to be in that order, by the way. The ordering of these functions is very important. You can't call a function that doesn't already exist. So we're calling that function here. That function's calling that function which now already exists. So we're going backwards, upwards. In C++, you're always programming upwards. Yeah, you do in C. No, I'm not going to say anything about any other language. That could be deflammatory. We've still got all of this object data to get through, yeah, and we're still on shaders. Should we try and create a shader? How do you destroy a shader? Well, if there's a create... So that's compile shader. Just give it the shader name. So what we're going to do is uint no, don't do that. Shader program 1 equals whatever we put in here. Oh wait a minute, I can tell from here, can't I? Because it's amber. Yeah, amber 3D. What are you looking at me like that for, Muppet? I think it's just create shader, isn't it? Compile shader. Got to get this right. So compile shader. There we go. What does it want? Shader name. Amber color. Let's try doing this one first. There we go. So that compiles and creates. GL create program. Oh, gold. Destruction time. Oh god, I forgot how to do this. Yeah. Is it GL detach? Shaders. I think it is. Let's have a look. It has to come here. So our shutdown is GL detach shader. That one. What do you want? A Gluint program. How about shader program 1? And a Gluint shader. Gluint shader, where's that going to come from? Isn't that just this GL shader thingy? That's a hash define. Okay. Shaders are uints. Okay. I'll do that for now because I don't know. We'll need the same again for the second one. I'm going to have to check this on. We'll put as much as I can remember in anyway. So paste. So you detach the shaders. And that's GL. Is that delete? God, there's a lot of deletes in here. Yeah, delete shader. 1. And that's GL delete shader 2. I'm just putting 1 and 2 in as a reference markers. And then we can GL delete the program. Which one do we want? That one. The program, which is shader program. That's how you delete a shader, but I am not sure if I'm correct in the way I've done it. So I need a module that uses shaders. Okay, let's have a look at a module that uses shaders. Probably module 3, a client might use them. It's got network, client application, client system. No, I'm thinking here. Open with Kate, please. What do we got? This just looks like a standard client. M running network, system commands, network manager. Where is your... Prepare, yeah. Application. Prepare, update, yeah. Client ID, so this is no window. Okay. I don't see a window on that one. Module 4. OBJ converter. No. Didn't like that one. That was rubbish. I'll try you, see what you're doing. Probably not a lot. Oh, this has got a display in it. What are you doing in here? Oh, shaders. Yes, you got shaders. Where's your shutdown? Your shutdown should be at the bottom. Notes. Delete from GFX card, yeah. Looks like I haven't done it. Well, not in here, I haven't anyway. So that's useless to me. Who would have done it? Let's have a look at you. Create a window instance. Yeah. Int main. That's your initialization. GL context, swaps, deletes, SDL quit. That was me testing this, wasn't it? Yeah. SDL logging. I'm gonna have to look this up. GL's detached shader. Okay. That's fine. Thank you, Kate. Pop you back out there. Never guess. Never, 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 never guess. It's the first rule of programming. GLD. Ooh, what was it? Detach. I'm having problems with, yeah. Detach shader. Yeah, right. GlueInt shader program specifies the program object from which to detach shader. Specifies the shader object to be detached. Detaches the shader object from a program. Yeah. This can undo the effect of GL attach shader. Yeah. Shader has already been flagged for deletion by call to GL delete shader, and it is not attached to any program object. It will be deleted after it has been detached. So I'm supposed to call that after the attach, am I? What does it mean by shader object? Have we got any examples? No examples, okay. Apple developer documentation. Yeah, well, that's great, but you're not really telling me what this is. Example. Thank you. Texture, OpenGL, error testing, shader compilation examples. Thank you. Always detach shaders after a successful link. Oh. I'm learning. Right, yeah, okay. So I've got to detach them after linking. According to that. Glad I checked now. So that don't go there. Actually, all of this doesn't. What about the delete though? Let's get rid of this a minute. Let's just copy this up to where we actually have the shaders. So this is where we have the shaders. Shader 0, shader 1, attach. Blah, blah, blah. Link. Check. Validate. There it is. So after linking it said, ding. So always detach shaders after a successful link. So we'll just take the deletes away for a second. Cut. Delete shader. Cut. Come here. It's not shader program 1 anymore. It's program ID. So you copy into there and there, and 1 is that shader 0. Copy to there. And there, and that's a 1. Right, that's successful now. Detach, detach, delete. No, don't do that yet. Cut. Right, that looks a bit better. So, we've done that. Where do we put the delete? Okay. Note the difference functions here. GL get programs. Yeah. Program IV. Got you. That's okay. But what about your main program? Sorry, I'm looking through this stuff here. How did your main program use this? This is garbage. Okay, well it's not going to give us anything else there. It's not going to give us a main program. No. That's a shame. They're usually quite good. Let's have a look at the OpenWiki on this one. Preempty, la la la, and detach shaders. See, it deletes them here, but you can't delete them anywhere else unless they're held within a class. Oh. Okay, thank you. So all we can actually do, get rid of that. Yeah, that'll do. No, just get rid of it. The movement is, once they're detached, they are deletable. So that bit there, I'm not happy with it being there. That's what he said. There's a hell to it. And here, if you make a program, GL delete a program. There we go, and that's just shader program 1. There we go. That should work. How will we know it's worked? Easy. It won't be 0. So all we do is we put in SDL _log, and we put in %u shader handle for program 1 equals %u, comma, shader program 1. There we go. Lovely. So that's how we know. So all I'm looking for is that message. Any other messages it gives, don't care. But can we actually create a shader program that easily? Let's see what I did wrong first of all. Okay. Let's see what I did wrong then. Okay. Vector mismatch size in that one. Compile shader failed. 2021. Okay. So we know that we've got an error. Keeping that up. Just for a second, whilst I have a look at my shaders. This is colour shader we're looking at. Debugging shaders. This is how you do it. I think it's in here. 2021. Vec 4 position 4. U model 4. World position 4. Okay. 2021. Might not be that one then. Let's try the fragment shader. 2021. I got a Vec 3. Going for a Vec 3. Vec 3. Hold on a minute. Let's have a look at these normalizations. V surface normal. Vec 3. To light vector. Vec 3. Don't know. V to camera. Okay. I don't see it. Arithmetic operator. Well, that's the Vec 3 equals Vec 3. Vec 3 equals Vec 3. Does that give... Oh, it won't tell us. Put a Vec 3 in, is it giving us a Vec 3 back? Right, we need to look at our error checking. Okay. Not enough information was given on our error, my god. So yeah, it tells us exactly where. It all depends on your graphics card, of course, and the manufacturer. But OpenGL tries to be nice and tell you where things are. But it's not that helpful sometimes. So, but at least it's doing it. When we check the error is program. Okay. Got to run it again now because I want to see the error again. Damn it. Oh, thank you. Because it crashes and it's fantastic. Compile shader failed. Okay. That one there, that error check there. That's the one that's failing. Why isn't it... Oh, we don't do a check before then, or what? And this one does the linking. Why does this one do the linking? Okay. One of our shaders don't match the other. Right, I'm going to add the Hmm. Simple. No. I haven't got a clue what it's on about. Arithmetic operator. Vector. It says 0, colon, colon. Oh yeah, it always says 0 because it's how far in to the line. That's not line numbers. Don't know what it is. We've got an arithmetic operator in the wrong place. Somewhere in our shader. Okay, checking shaders time again. Dum 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 dum. Main go away. We want shaders. No, I'll check the one first. No, looks good. Looks good. U model 4 position 4 equals a 4, yeah. GL position is a 4. U protection 4. U view 4. U model 4. Position 4. That's fine. V color 4. Color 4. Lighting stuff. V surface normal 3. Vec 3. Do it properly. V to light vector. U light position, Vec 3. World position. Vec 4. To light vector is a Vec 3. Hold on a minute. Hold on a minute. This line here. To light vector is a 3. Light position is a 3. World position is a 4. So it's that one there. I think that might be how you do it. Okay. Get rid of the bash there. I'll just check the rest anyway. Can you return then? No. Oh, stop it. It's gone wandering off on itself. Okay, so I've checked that one and I think that's better. Camera vector, I'll do it anyway. Is a 3, Vec 3, open bracket, minus world position again. Yeah, I've got the same. I think I've done the same here. I'm not sure I need it on that one. But this one's wrong. That bracket. Oh, stop it. Just the bracket. Okay. If I put that bracket there. Does that make it any better? I don't know. Let's try that out. Saved it, yeah. Test. got a different error now. Comma or... compile shader failed now. I know which shader it is. We've just messed around with these two. Take that off. Now everything's got semicolons on it, so yeah. Interesting. Error, syntax error, comma, unexpected, void, tdk, comma, expecting, comma, or semicolon. Okay. Oh. Oh, ice cream's just been cold. I think I might be taking a break. XYZ. Let's just try that. It's the longhand way of doing something. Nope, still doesn't like it. Damn it. Right, I'm going to have to take a break anyway because the ice cream's arrived. But yeah. Yeah. It's looking for things which I can't provide. So I'll put it back to how it was. Like that. And I'm going to go and take a break. So, I think that bracket was definitely wrong there. I think I might just put vec3 and bracket that. Or vec4, oh, don't know. Right, I'll mess around with this line and see what it really should be. So I will catch you a bit later. Take care and have fun.